All right, so today we're going to go over an 820-3209 that doesn't turn on. So today I want to show you how it's really important to know where the original damage occurred so that you could figure out problems that would otherwise be a complete, utter nightmare. So when you look at the actual machine itself, you're going to see that there are these little marks, and they look like just little stains of pigeon shit that you would see on the sidewalk. And if you look at it under the microscope, you're going to see this. This is going to be really helpful if the board is cleaned before you look at it and you have no idea where the original damage occurred. So when I look at it under the microscope, let's just get in focus. So I have some here, and that's the pigeon shit looking stuff that I'm talking about. And then a really main one that I'm interested in is this one right over here. So what I do is I look at I'm going to look at the motherboard in those spots. So again, this is a board that was fully cleaned before I got it, so it's great because I don't have to actually waste time ultrasonicing it and dealing with all that shit. But the downside is I don't know where the actual problem is, and it's going to take a lot of inspection. So, but knowing where that was, what I'm going to do is I'm going to match up that little spot of pigeon shit on the board with this, and what I see is this. And you can tell, like this is something that I would miss going over the board with my eyes. I'd probably never ever see this. But now it's really obvious that there's a problem here with this IC. See that? So what I'm going to do here is I'm going to go over to the board view software, and we're going to check out on the board view software what that is and what that does. When I go to the board view software, what I see is, let's just get it back in a view. This board view software is crap. I mean, I'm sure any of you who've been doing this, you're fully aware that this stuff is garbage. Let's see. I don't give a fuck about your birthday. You sell crappy screens. Go away. Let's see. Okay, here we go. So it's a burn piece. I'm not as good at Pac-Man this morning as I usually am. There you go. So pin 20 of U7100. Damn, this program is sucking more than usual, which is PP5E-SO on U7100. So this chip, U7100 here, this chip is responsible for creating an SO power rail of PPV-CCSA_SO_reg. So let's just see what this is responsible for. So this is created by U7100. It is, let's take a look. It goes through R7140 to no real idea. So let's see on here where that goes. Of course, it's not found. It's probably called something else on here. All right. Of course, it's not. Who are we kidding? Okay, so the schematic says that you should find it on R7140, so let's see what that is over here. So that looks like a current sensing resistor for this. So, okay, so they call it something different over here. Go fucking figure. So yeah, it looks like something that goes to the CPU. Yeah, so you can see over here that this is pretty much used for the CPU. Now, the problem here is that I have an SO rail that I'm going to take a wild guess that SO rail is missing because that chip is actually burned. So again, when we go back to U7100 on the schematic, you'll see that U7100, that pin that's burned is one of the VCC pins over here that's required for this chip to actually turn on. And this chip is used to control this buck regulator, which is going to take buck converter, technically, which is going to take this higher power over here, PPVin, SO, VCC, SA, whatever, and it's going to turn that into this PPVCC, SA, SO reg rail. So let's just take a look at where that comes from. So this comes from PPVin, blah, blah, computing iSense. That comes from PPBus G3 hot, as you can see. So let's say we were just to take, this is the rail. That's a sub-rail of this one. We take that rail, and we see that that rail is, well, you know, it actually doesn't list it as a sub-rail of this one, does it? PPBus S5 high side computing iSense PPVin, same shit. It really is the same shit. Like this is the same as this, which is the same as this. So what this thing does is it takes 8.4 volts, and turns it into the whatever voltage the CPU wants. Now again, we can take a wild guess that power rail is missing because pin 20 is the one that's burned, and that's a VCC pin. As I've explained in other videos, the VCC pin, the VDD pin, the VN pin, whatever that is, think of that like the pins on the back of your soldering station where you plug the IEC cord in to turn it on. So this is where you're expecting power input, and power input's not there. So the first thing I want to do here is I want to see, is the board actually in an SO state, an S4 state, an S5 state? What power state is it in? So SO is, again, keep in mind, all these Core i5, i7 series MacBooks, they're designed to turn on from the second you put the charger in. So as soon as I plug this charger in, it should turn on. The fan should spin. I should start seeing SO rails become present. So I want to see what state I'm in and work my way down. So what I'm going to do over here is I'm going to see if I have an SO rail present. So let's just go back here, and let's search for PP5ESO and see where that shows up, because that is an SO rail, PP5E_SO. Let's see if there's any easy places to measure. On this side, not much in terms of easy places to measure. This software is just downright awful. All right, so we're going to measure for PP5ESO. And here's a good space to measure for it. It's a good spot to measure. So okay, so we have the multimeter over here. So now the board is plugged in, it's not on. You can see it's pretty much dead, you know. You have a light, but it's not actually powering. So what I'm going to do is I'm going to measure the voltage on PP5VSO. So PP5ESO is there. I have 5 volts. So this means that the machine is, here's the good thing. It's really hard to get things like, let's say, PM sleep S4L, which is what gets the machine, you know, into an S4 and S3 state. It's really hard to get stuff like that going when it's not there. That can be a royal pain in the ass. That can be a lot of different things, and it's very often, to be quite honest, a total nightmare. But this, 99% of it's already there. You have your green light. The SMC's going. It's doing what it's supposed to. You have your steady S5 rails, S3 rails, and SO. So again, the machine's going to be in an S5 state. Then it's going to try to enter an S3 state, which is sleep or suspend. Then it's going to try to enter an SO state, which is I'm on and I'm working. If you don't know what that is, Google the power states of a computer. S5 is either off or hibernate. S3 is suspend, sleeping. Like when you see a little white light blinking on the front of your MacBook after you close the lid, it's not off, but it's not on either. And then you have SO, which is when it's actually on. So 99% of the hard stuff here, again, it's done. I got a light. I have my main power rails are there. All I'm missing is, I'm going to take a wild guess that the CPU one is missing. And again, I'm not going to do a lot of research to figure it out. I'm not even going to bother measuring the rail. What I'm going to do is I'm going to do the things that I can do with my brain off. Now, one of the things I talk about is knowing when to have your brain turned off so that you could kind of save it for the other stuff. So you can use your brain to kind of try to figure out what's wrong with this and go through every single rail in the sequence, or you could just go, there is a big blotch of green stuff over here. Use your brain just enough to try to figure out where that is on this board. Look and see that there's a thing on this board that's burned. Again, let's just go over what's burned. And also, what that tells me, since that PP5ESO pin is burned, that means that anything else that's going to be on the PP5E_SO bus may be burned. So let's say I replace that and I get that rail, but something else is wrong. I'm going to look for things that are powered off of the PP5ESO bus. What I can assume here is that the PP5ESO went high for a second, so maybe instead of being 5 volts, it was 6, 7, or 9 for a split second, and that's what caused that to blow up as a result of the liquid. So let's start with this, and if this doesn't work, we're going to look at the other things on the PP5ESO bus that could be wrong. So back over here to the microscope, I'm going to turn on the soldering station, turn on the rework machine, and let's get started. So this is my chip. So I'm just going to get that thing heated up. It takes a second for the hot air to heat up. You know, the FR801 isn't new anymore. And I'm going to get myself a few donor boards, 1 or 2, just in case the one that I pick out of the bin is missing anything that I need. Most of these donor boards are missing everything that I need. They've been thoroughly sodomized. Actually, almost every single one of them is missing the thing that I need. All right, so the hot air station should be hot by now, which means I could turn on the fume extractor. One thing to note if you're doing any of this type of work, I know it's annoying to have this thing on. It is very loud. You can't hear it in these videos because I use isotope RX4 to remove a lot of the noise. You can hear a little bit of it, but you can't hear all of it. And I also have a microphone really close to my mouth. So the reason I have this mic really close to my mouth is so that you can't hear just how loud a lot of this stuff is, so I can actually provide instruction during the video. But this thing is annoying as hell. But as annoying as it is, the alternative, which is inhaling flux fumes all day, is really a really, really bad alternative. I'm going to take that capacitor off too, because let's face it, that's junk. So what I'm going to try to do here is I'm going to try to tin the pads with my standard iron, and I'm also going to try to scratch away a lot of that corrosion. While I'm here, I'm going to try to do both at the same time. So I got some quality Amtech flux. This is the Amtech NC559 V2 TF. And let's see what we can do here. So I'm going to try to remove the old lead-free solder, add leaded solder, and also kind of scrape away at the corrosion all at the same time. So we have a little bit of an ambitious task here. Now I'm going to use the other end of the iron to kind of just some little gentle scraping. But it seems like the bottom of that pad is too far burned for any gentle scraping to do anything. As you can see, I've scraped away at that entire trace, and I haven't made any progress at all on there. So now I'm going to try scraping away with the micro pencil. Okay, so the FX951 bitches a little bit when you switch from one iron to the other. You hear there's like 4 beeps in a row. The whole idea behind the 4 beeps in a row is that it's pissed off that I didn't buy the FM203. And I understand that it's pissed off that I didn't buy the FM203. I get that, but I don't give a shit. Fuck you, I'm not giving HAKKO more money when I can literally hang this stuff. Like I get right now, I have a little screw in my wall, or a nail, screw, whatever. And I coil up my old iron with the other iron, and I put it right behind me. When it's time to use this, I plug it right in. You know, as dumb as this is going to sound really dumb, but while I was at Practical Board Repair School, Jessa has the FM203 and these other irons where you switch one on and switch one off. And HAKKO doesn't really have like a regular setup for it. It says S and D. So one of the things I was talking about in my reviews of the other HAKKO gear was how annoying a lot of the interfaces on a lot of these products. And you know, again, like on this, you have this alarm clock, 1980s alarm clock interface that's really, really, really just not user intuitive at all. And she has one where, again, it says S and D. And like sometimes I don't know if you're supposed to hold down the button to switch between them. I don't know if you're supposed to, like if you hold down the button or if you press it twice or you press it once. I can't tell when this shit's on or off because, again, there's one number on the screen. Is that for the left iron, the right iron? Who the fuck knows? The JBC station is very, very simple. It shows you which iron, what temperature, which iron is at. You know, it makes sense. The HAKKO one does not make sense. So what I do is, and again, the thing is, I could spend more money on the HAKKO station that's dual port for it to not make sense. Or I could use my existing station and do what works for me, which is to plug that shit, you know, just plug the iron in. And then when I'm done with it, I unplug that iron and I plug my other iron in, which is hanging right behind it on the wall. The other benefit of this is that it takes up a lot less space and in where I work. So again, if I were to show you where I work, you know, look, okay, I'm going to move the microscope out of the way. Look, when I move the microscope, this almost comes off the table. So this is my hot air station. This is my soldering iron. This is my, this is my stand. I don't have space for 2 stands here. If I put a stand here when I move the microscope, the bar is going to hit it. If I try to put another stand here, it's going to fall off because HAKKO doesn't make gear flat anymore. Why they don't make gear flat anymore is beyond me. This thing being flat is... If I had the new FRA-10, this station would not work. You have to understand that. This being flat and me being able to put this on top of this is the only reason that this works. When you look at the HAKKO FR810, the new one, which I will never ever recommend you buy, just based on the fact that they've made it not flat. Really, it's that important. Like you can't stack. I need my workspace. I have a 200 square foot office. So what I do over here, as you can see, is I have a little nail in the wall. So I'm just going to move back so you can see it, and my iron is right behind me. So again, when I want to switch, none of that paying an extra $100 or $200 or $300 for a different station bullshit. I literally just unplug it and I plug it back in, and I know when it's on. I know what temperature it's at when it's on. I don't have to deal with the alarm clock bullshit to tell. Anyway, it's small detail from the actual video, but back to our regularly scheduled programming before I decided to bitch about HAKKO and their interfaces. Is that a hair? Ugh. So anyway, so what I did there is I just ran a jumper wire, because as you can see, the pad was there and the pad was savable, but the problem with that pad is that it wasn't actually connected to the trace. So if I were to solder that on, I would have never gotten PP5 VSO. So what I did leave a little bit of the pad there, because leaving a little bit of the pad there means when I heat this end of the wire to get rid of that little excess solder that I see. Yeah, I just cleaned the hair off of the flux dispenser. What's going to happen is it's not going to jump away from there. See what I just did there? If that wasn't soldered over there, the wire would have just came right off with it. So now I'm ready to put another chip on. So I'm going to go to my donor board that actually still has that chip. And the donor board that I took that chip off of actually has a chip that is more burns than the one that I'm currently working with. Are you kidding me? Let's see. What does it look like? Yeah, you see how it's missing half a pad? Fuck that. This is bullshit. Yeah, fuck that. I'm not using this. Next. This board has a hole in it, and obviously the reason it has a hole in it is because somebody didn't know that they could fix the SO rail for the CPU. The amount of these boards that I look at where, like, it has a hole in it, but I know the original problem was fixable, is getting higher and higher. I mean, ugh. If this had been given to me, I would have fixed it. That's a maybe. Seriously? All the whole boards have a destroyed CPU V-core circuit. I gotta find these people and offer them like maybe a group rate or something on the training course. Seriously, these people would be rich if they weren't throwing this crap in the garbage. I don't understand. Why are you throwing this away? You're selling this crap for $15 to $30. You're selling it for $169 or $250 or $450, depending on what model the board is. God, it's fucking stupid. So fucking stupid. What's really stupid is putting the hole through it, because if you didn't put the hole through it, none of this would be a problem to begin with. Alright, so let's remove that chip from the donor board. Let's move the fume extractor over, put some flux down there. Okay, so the donor board is going to be over here on the desk, so I move the fume extractor right over. I have flux on it. Now I move my fume extractor back over here. Pray that this chip doesn't run away while I change open broadcaster back to the microscope. This chip had better not fly into my air filter. Now, see what I'm doing? It has to be pushed down on the board. That's important. If it's not flat on the board, it won't make contact, and this won't work. So then I'm going to go around it with my micro pencil, and we're going to make sure that it's actually soldered on there properly. I feel each individual joint as I go. Those ones are going to be of particular interest to me, obviously. Anyway, now I have to put that capacitor down there. So much reflection. It'll become clearer to see once I use the hot air. Now I want to make sure that my jumper is in place. So what I'm going to do is I'm going to hold the jumper properly so that it doesn't move away or stick to my iron while I solder it directly to the chip. Again, I really want to make sure that that jumper is soldered straight to my chip. I want to know that that chip is getting PP5 ESO. No reason to keep a little solder blob on the side there. You can get rid of that. Okay, so now first thing I want to do is I want to see if there's any change. So I remove that issue, and let's see if I have any positive results. So, you know, plug in the. As you can see, my fan is spinning, which, you know, let's not ruin the excitement or the fun. My CPU I MVP ton resist TON for time on. I like to call ton. Resistor is looking good, so I'm pretty sure that that means I'll have V-core. And yeah, so let's just go over this again. So the whole idea here is that when you look at the act, this is why having the whole computer is something that I really ask for from people sending stuff here. Seeing the entire computer allowed me to do this diagnosis, have a commentary while half asleep, and still fix the board inside of, what, 20-something minutes? Whereas without that, it would have taken a lot longer. If it took a lot longer, it would have been lower priority. Lower priority means longer turnaround, and it's just, you know, this makes everything just that much easier. It's that much simpler. So what a lot of people think is genius is really just me having some common sense and following along and looking through to see what it is that was wrong, and just based on where the damage was. And then again, I can come up with a theory as to what happened based on that. So something like this is kind of what tells me that an SO rail being not present will keep it from turning on, but it can still enter an SO state. So like a few years ago, this entered the knowledge base. I know that this board is in it can be in an SO state even with a rail missing. It's not going to just jump back to an S3 state. Everything's going to turn on except for that one rail. You just kind of learn this stuff just from poking around, just from looking at stuff that you otherwise wouldn't have looked at. But yeah. Okay, so remember what I said about how the fan spins, so I should be good to go, right? I completely missed the entire backlight section of the motherboard, none of which was actually working. So let's just take a look here, and so we have the switch trace. We have this line that comes here for backlight enable. This is what we actually worked on. Here we go. That was for the CPU power. We have Oh, it gets better. So the LCD connector was missing pins 3 and 4. They usually burned. Here they were actually completely 100% missing. So that was some fun right there. Then we had right over here. So that's where it's going to the backlight enable resistors. That is the new backlight fuse. That backlight fuse is going to this resistor, which was responsible for the voltage divider that's going to send power through to the whole machine. This was fucked. And now it is slightly less fucked, which is a good thing. And hopefully this actually is going to work perfectly past ASD and be good to go. Because I know one thing's for certain, I am not spending another second on this board.